everyone. Welcome to this webinar. Welcome for all of you to join us today for the webinar from Scan to BIM. From Scan to BIM, a real factory case with mobile scanning and 3DGS and multi-layer visualization. I'm Mindy Lee from S-Rays, and I'll be your moderator for today's session. This webinar is part of our ongoing effort to explore how mobile scanning and 3D Gaussian splatting and new technology are moving from exciting concepts into practical workflows with real delivery value. And today's session, I'm very honored to have three speakers joining me. And please, each of you, please give us a very short introduction of yourself and your topic today. We will start from Philip and Bert and CRISPR. Philip, please.
Okay, hello, I'm Philip. I'm from Posh Preview, and I do the scanning. I have a scan to BIM company, and I capture with the mobile scanner the data, and then I'm going to convert it to a BIM model and draw it.
Yeah, great. And Bert?
Hey guys, I'm the CEO and co-founder of Nubigon Inc. We specialize in developing a rendering software for the reality capture and scan to BIM industry.
Yeah, and CRISPR?
Hi everyone, I'm CRISPR Aguilar. I lead visual direction at Reality Render Studio. We usually work with AEC teams and reality capture workflows, helping them to present their data in a way that makes sense for their clients and stakeholders.
Yeah, thank you for this short introduction. And later on, we will go into a meaningful case because we are not talking about concept or a demo in isolation. We are walking through a real factory scan to BIM case from the very beginning of data capture all the way to BIM delivery, multi-layer visualization, final rendering, and validation. What makes this case important is that it helps answer a very practical question: how far can mobile scanning and 3DGS really go in a production level AEC project? And even more importantly, can all these tools help make scan to BIM workflow faster, more scalable, and easier to communicate across teams and stakeholders? Exactly what we'll unpack today. And firstly, I will give the mic to Philip today for his presentation. He will give a very dynamic and lively one to showcase his projects as well as the software and all the tools he used.
Okay, so I'm going to show a project of mine, which I did because my client wanted to have new sheets and new plans and a completely 3D model of an existing building, which is a lot of MEP and a lot of technical in there. It is a building from a hospital where all the energy comes in. And they hired me to scan the whole building and to create a BIM model to process further any kind of construction if they need something to rebuild, and to hand over other companies the new BIM model, because with a scan and with old PDF sheets nobody can work, and that's why I digitalize them in 3D to them, that they can work with it. I can show you some examples. At first, my company, just to give a little bit a short overview. I will share my screen. So now my screen should be visible here. Exactly. For example, just a short overview from my company. This is my portfolio. This is my company, which I created and founded to digitalize buildings and to create some digital twin of every building you need. And here I offer some laser scanning and the scan to BIM process. Here you can see the picture, which for example, in this case, already this building in this case study, I'm showing, you can see here is the point cloud, and here is already the finished BIM model, and we create the sheet plans as well, where architects can plan accordingly on that. And we have different level of detailing. Here, for example, here is just the volume, and here it gets more into detail from LOD 100 to 400. Here, for example, I have some that you get an understanding of the idea, what the difference between the LOD 100 to 400 is, that you have an idea what is the different scale and detail of everything. For example, walls, ceilings, doors, how this railings and roofs gonna look like. And as well for the MEP parts, for example, for the boilers, for the pipes, for the ducts, for mechanical systems, that you just have a volume here, and here you have it directly as it should be built in real life with every little detail onto it. Here in my portfolio as well, you can see this, for example, is an old PDF sheet. I can open it. This was just a scan. This was the PDF sheet they had, and this is just it. And as you can see, nobody can clearly, especially in this age, can work with it. So an architect and a survey needed to work together and measure this up and then redraw it. And I combined this whole workflow to get even a faster result, that the planners can accordingly adjust the new things they want to make. And when to my portfolio as well, offer virtual tours, one time with photorealistic, where you can even see this. Don't worry, in this PDF it's a little bit compressed, but normally you can see the textures, which is very important. And the part what is X-Grids offering as well with the mobile scanner is the 3D-GS, the Gaussian splatting, where you get an idea how the building is looking, and everything is not 100% that you can read it. It's not that precise that you can read every text, but you get an idea how the volume looks, how the structure, how the RGBs, how the dimension is. And as well, I do some renderings as well before and after. And this is the thing to my company. And this is, for example, the PDF I created. This is the 3D BIM model in LOD 400, and you can extract here as well floor plans and sections and views. And here, for example, I can share a video where there is some kind of showcase where you can see this is the 3D BIM model, and I made a transition where you can see the accuracy of the building and how this is gonna look like. For example, here you can see the point cloud. It has a very good and a very nice scan accuracy and scan point data, as you can see here how it looks in real life. And I draw this accordingly to the point cloud. This is from inside. Here you can see the point cloud again and how the transition is. And with a point cloud, it's like a shadow. An architect cannot work with it, but with a BIM model, they can work with. And you can see the transition. It's very accurate and the perfect tool for an existing building or the documentary when the building is currently under construction, that they can work with this model as well. Here I have as well another animation from my company, how this whole process looks. For example, here I do the scanning, and this is how the building looks. You scan, get the point cloud data, you process it. Here you have the point cloud. Then afterwards, you import it into Revit, and in Revit you can use this as your measurements and can see it in Revit directly, and then draw it accordingly based on the point cloud data. I have here as well a screen record how this process, for example, looks like. For example, when you want to, let's see, for example, you see here the point cloud in Revit, and you do a split screen. And here, for example, here I picked up the boiler and wanted to give it to the same location and the same scale and size as it is in the point cloud. And here on the right screen, you can see it in the 3D view, where I put it accordingly on the right position and in the right dimension. And here you get somehow the idea how I'm going to draw the models. And this process needs to be done manually. I provide the service. And here you can see in the section, you can adjust the height, and that's how about and you can adjust the angles, and that's how about the process is going on and for every element. So the more it is packed full with MEP, and the more complex the geometry is, the longer it takes for sure, and the more detailed you need to get it. But this is still a manual process. But I think it needs to be done very precisely because it is very important that everything is on the right, has the right scale and is on the right position. Because when you plan it wrong and then you come in the construction field and everything separates from the PDF plan sheet you was getting, it doesn't make a sense. So a scanner is optimal to use here to get some idea how the old building looks like. And I can show you as well how this is the software from Xgrids directly. This is the point cloud I was getting out. This is the processed version. And here you can see how the point cloud looks, and it's still capturing a lot of data as well. As you can see, the neighbor buildings, so the scanner is reaching a lot of distance. And you can see when I take here, for example, I cutted this, that it looks more clean. And when you pick up, for example, the clip box, just for the showcase, here you can make some clip boxes, and here you can see, for example, how the point cloud looks inside. And even if you don't draw any 3D BIM model, it is still good because you can take measurements here as well, and you just can measure how tall is this boiler, or how many steps staircases do you have, and can create precise you get a lot of information just from the point cloud. But in this case, you need to have some kind of expertise to use this tool. But this is how the point cloud looks. And I can show you in Revit as well the 3D model. This is, for example, the 3D model as it's drawn finished. And when I here I hide the walls for now. I'm going to hide the walls that you can see the inside as well. It's loading. Okay, I don't know why it's loading that long. Okay, now it's working. As you can see here, these are CAD 3D objects that you can dimension, that you can change. So basically the best thing for an architect to work with, because it's already a finished model, and they can say, okay, we need to adjust here the two boilers to another thing, and they can just move them to another part, for example. And the last thing here, what I can show you as well, is the 3D.js, as I mentioned in my company portfolio. Let me open that. So it should be done immediately. It should not take that long. You can share the view as well in the browser. So that is very good for users or your clients, even if they don't have any kind of viewer, that you can share it in the browser. And therefore you can see and can move directly through the room. And as you can see, the quality is really good. And you can see based off the panoramic pictures, it's getting out from the scanner. You get a lot of information how the building looks like. And you even can take here some measurements if you want to here in the toolbar. And I even climbed up here on the roof, even with the scanner, so it worked. So props on that. And you can see here on the roof as well. So basically everywhere you go, you get an idea how the place looks. And it's a good add-on that because normally just based on a point cloud, you don't see that much. And here you get a basic idea what the actual construction field and the current building looks like. But as you can see, this is all based on many panorama pictures, so you cannot read anything here. But for the overall view here, you see perfectly everything how it's built. And for example, big things like this, for example, you can read it 122. So if there is any kind of bigger number or something, you can easily read it. So let's close this. And so basically this is here. We have still the movie. I don't know if Nubigon wants to show this, or I can show it as well. The video, what was created by their side with their software, but I think Nubigon will show this, so I will let their product them. This is just my project, and then I will let them showcase this. And yes, that is basically everything from the case study. So the scanning time was round about 1.5 hours. So it's really quick. You get a lot of results from it. It is very accurate. In this dimension, you just have accuracy problems like 1 to 2 centimeters at all. So if you just want to have a very quick, very fast point cloud, that you get an idea how this building looks like and that you need some kind of BIM models for them, it is the best possible, cheapest way. And I provide this service as well. I do it in whole Europe. And if you want to contact me for scanning, I have several partners as well in other countries for scanning. And the drawing part I can do as well. I'm specialized on MEP because not everybody is able to draw this because it needs some kind of technical information. But if you have any project and which could be interesting, feel free to contact me anytime. But I think now you have a basic idea how this workflow looks like and how this everything goes on. Thank you very much. Mindy, you are muted still.
Sorry. So can you hear me?
Yes, I can hear you.
Yes, great. And thank you so much for these presentation. I think is still a very dynamic one. And I noticed that many of the audience have posted their questions here. And firstly, I must answer that whether these session will be recorded. The answer is yes, and or the session will be recorded. But if you have any questions, and you can get a live answer here if you post them in the comment area, we will answer them, or the speakers will answer them later. And let's
yes, for
choose
sure.
some.
Or even if they just rewatch the whole webinar, they just can text me on LinkedIn, just send me an invite, and you
Video.
can just text me if you have any further questions for this.
Yes, yes. So firstly, the questions will be left in the LinkedIn comment area as well. And if we didn't go, if we couldn't go through all of the questions here in the webinar, all the speakers can also go back to the comment area to answer them. And if you have any of the private questions, and you can also reach out Philip and any of the speakers for further discussion.
Yeah,
And
for sure.
let's find some question for you, Philip. And I think people are very interested in your project. And let me find one. I'm not sure. This one is maybe is not a relevant one to your project, but I would also know whether
It,
there is some requirements from your projects
yes, but
require
it
a
is
georeference. Yes.
it is it is actually an important question because service and my scanning part, it is always very important that you have that it is georeferenced because most of the projects needs to be placed in some kind of that every plan from every planner is on the same scale when you just reload the point cloud, that it is on the correct position. So this is an important question. And the 3DGS is a local file. The 3DGS cannot be referenced, but you can reference the point cloud because the 3DGS needs to have a local system. And with the point clouds, you can work with an RTK and connect with the satellite and import the GNSS data. And then you have the same location for a coordinate system. And
exactly.
absolute relative accuracy as conservative laser scans method. Is there any trade-off? Yeah, for sure. It is a little bit of trade-off because mobile scanners will never be as accurate as terrestrial scanners for sure. Because of at long distances, maybe half a degree will be wrong, and then over 100 meters you get a little bit of slope in the scan. This is the only issue, but this is normal with the mobile scanners, and the accuracy is still not the difference is not that big, and you can work with crowd control points and with the RTK to improve accuracy. So there are a lot of ways to work with it.
Yeah, exactly. And with those RTK and or any control points, you can also make those 3D be geo-referenced. And nowadays, we also provide a solution for CSIM, and you can also put that
Okay.
into your CSIM
Now I haven't tried the 3DGS to georeferences because I don't know why you should use to, because you always have a local system. But with point clouds, I have done it, and that is, in my opinion, really, really important to do.
Yeah. To get a better accuracy and result.
No, that the point cloud is on the correct position because many companies are working with it.
Yeah, to position them in a correct map.
Exactly.
Yeah, and let's go to another one. And you also mentioned the accuracy theme, and the skip also have this question: what is the current accuracy spec tolerance? I think it's also a very important question for the scan to beam projects, and you can also tell it a general requirement.
It depends on the environment, how the lighting conditions are, how big the scale is, how complex the geometry is. But in most cases, for the most projects, let's say 1,000 square meters, you have 1 to 1 centimeter difference, 1 to 2 centimeter difference at max. At max, it can be perfectly accurate as well. This always depends on reflection, on how much georeference points to use, how much angles do you use to scanning, what is your starting point, do you work with an RTK? But in general, you can say 1 to 2 centimeters. There you get the difference.
Mm-hmm. Yes, and let's move on to the next one. How far are we still from the Matthias? Or how far are we with producing a proper BIM model automatically to cut down drawing efforts? So have you already tried any of these kind of
Yeah,
tools?
I tried some AI features as well. and I say they are promising more that it actually works, because there are some softwares they can do the basics with some walls and ceilings, but everything needs to be accurate, and there are some errors on it, and then it's much more effort to correct this. And when it's some getting a little bit complex from the geometry and MEP, and maybe the scan data is not that beautiful because you just have one angle and the lights are bad and so on, the software cannot process it. So currently, I think it takes, we don't know, because AI is growing exponentially. But for now, I will think realistically, because I have seen this was already 2 years ago, a really big topic, that automatically export the files to get the BIM model. But I will say, let's see, you cannot say how good does it work, but for now, no, I think no prototype is really practical to work with. But I will say in 2 to 3 years, it can happen a lot. I think it can be a realistic scenario, but the scan data needs to be good and really clean and beautiful for that. And that is not always the case, especially for me when I scan this like dark, trashy environments, and there you don't have these perfect scans, and you need the manual eye for this, that you sometimes assume some things where this pipe can go through when this is the other end, for example.
Yes. And from our side, Asgris also tried to provide more AI functions. And we find that the first step is still very important to get a very clean capture data. And then and try to make some first step for the AI solution is to try to do the spatial recognition. And nowadays in LCC Studio, we already provide these functions for that. The walls, ceiling, doors, and the windows, but they are very basic functions to help you to reduce the time.
Exactly. You just get, currently on the market, they're just a recognition, and they point the point cloud, for example, all the door red, all the ceilings yellow. And I think it is not really an help currently, but let's see how the future goes. Maybe there will be a brilliant AI.
Yeah, maybe AI is not a replacement for the people, but it's a co-pilot at this moment.
Exactly.
Yeah. And this part is going to an end, and we will introduce Bert for the next part. And if the question is not answered in this part, all the question will goes to the last part of our webinar today. And thank you for Philip's sharing. And then let's give the mic to Bert.
Hi, Mindy. Hello, everyone. Let me get started with the slideshow. Mindy, could you pull it up? There we go. Perfect. So I'll give you a little bit of a background, and then we'll, at the end of the presentation, we'll do the big reveal of the animation that we have prepared for this session. I'll be talking about multi-layer scan visualization, in particular, how to visualize point clouds, BIM, and most notably 3DGS together in one scene, and to discuss specifically how this can help elevate scan to BIM projects, both in terms of production as well as delivery. So reality capture, no matter what method or what hardware you use, is the source of truth for any scan to BIM project. It builds the foundation for any modeling work that comes on top of it. However, once the model is developed, then the reality capture data gets a more secondary role in the entire workflow, and oftentimes the client doesn't even see the original reality capture data, so the discussions revolve primarily around the BIM model. This is a significantly missed opportunity, and the primary reason for that is scan to BIM is not only valuable in terms of the quality of the model, but also because it's anchored in reality. So all the effort that goes in, the cost, and ultimately the trust of the client is based on the connection between the scan and the BIM. Now, if you don't communicate that clearly, then we're not using, or we're not generating as much of value for the client. And this is something that we would like to address with our solutions. Now, typically what we help our clients to do is to enable their clients see both the scan and the BIM data together in the same setting, help them understand the process as well as the quality of the work, so that they can ultimately can trust the outcomes. It obviously all starts with the big alignment question. Anyone who's worked with Recap, Revit, and various other BIM pipelines knows how important it is to pay attention to alignment. And the issue gets even greater when you take the data out of Revit and try to pair it with any point cloud data set. Those alignment issues can be quite significant. We've been lucky enough to work with Autodesk on this topic, and to be able to to import Recap and Revit files automatically aligned as they are in Revit, so you can directly work with them in our application. Now, if you go back to the slides, Mindy. I don't think I see the slides on my screen. There we go. So that's the alignment is the starting part, and it's not sufficient. One thing that I would want everyone to take away from this presentation is that no matter what method you use or what hardware you use, there is a suitable way to present your scan data. Now, obviously, the photorealistic display is a quite potent display method, and Gaussian splats especially are making a huge progress in that end. This is a data set was captured with an X-ray scanner and rendered in our application, and it is, for many users, the most intuitive way to view and explore a data set. If you're working with high resolution point clouds that come from other types of LiDAR scanners, there are ways of delivering a photorealistic display as well, especially in the industrial context. Obviously, terrestrial laser scanners are still quite popular, and with a combination of RGB colors and the physically based rendering that we developed for point clouds, you can actually get incredibly detailed displays for high resolution data sets. Photorealism is not the only way to present data, especially if you're talking about scan data. It can work really well, especially if you're inspecting surface details, and with high resolution point cloud data, you can get incredible displays from your captures. Intensity is another interesting display method which allows you to distinguish materials, which is going to be promising in the near future for material detection in the AI context. If you have complex sites where you have intricate room arrangements, this is obviously quite present in an industrial setting, or if you're working a lot of low resolution, low density point clouds, then the X-ray works really well. Here we see an example that applies elevation and X-ray to the point cloud. If you are lucky enough to work on a very large project like this train station project in Spain, obviously the X-ray is quite useful because it allows you to penetrate beyond the line of sight and give you a much clearer view of the scope of your projects. Now, once you have your point cloud displayed and you're happy with that, you can add insight to it by combining it with different models. In this particular case, a 3D model, just so you can communicate the difference and the transition from a point cloud to the 3D model. If you have complex sites, clip animation work really well in simplifying the scene and what the viewer views. These are all quite useful methods of making every type of client understand what goes on site and the scan to BIM project involves. Here was an example from a recent project in the Netherlands where the point cloud provides context, and the 3D CAD drawing here also example shows what has been accomplished at the end of this project. And ultimately, you want to be able to deliver these visuals in a way that everyone can understand. The visuals, that go on websites, that go on project presentations, that go on social media posts, on ads online, you name it. These are all different types of visual deliverables that all have to be at high quality and accessible to people for them to consume. Not everyone is in a position to go into an online viewer and explore a data set and actually make sense of it. So we need to catch people where they are and reach them at a level that they can understand. So maybe we can replay that video of Mindy that's called Dennis Sprung, and just to give that transition from the BIM model to point cloud and ultimately the architectural rendering of it and back. This is a beautiful GIF that summarizes the transition in a very succinct way. Now, thank you, Mindy. Ultimately, the main mission here is to reach people that may not fully grasp the details and the effort that goes into scan to BIM, help them appreciate the value of it, and ultimately reach a greater portion of the AEC space, so that scan to BIM can become a more widely available solution to the overall industry. What comes next for us is to distill everything that we have shown you so far in terms of point clouds, 3DGS, and BIM models, and add a layer of analysis and another layer of decision making. In this case, it'll be sun and shadow simulations where you'll be able to apply and simulate sun and shadows onto point clouds, BIM models, and iterate different scenarios, analyze how the sun path trajectory affects your site, how your new designs affect existing conditions, and so on. So I'll stop here, and I will ask Mindy to play the video that CRISPR has prepared for Philips, not this video, nope.
Is this one?
No, the video that CRISPR has prepared.
Okay, I think I didn't get that one. Maybe CRISPR can share that video later.
All right, so I'll leave it at that. And if you have any questions, obviously feel free to shoot them over. Otherwise, I'm happy to join the discussion later on.
So your part has finished yet?
Pardon me?
Yeah, and thank you for this. And we really noticed that the context to overlay different kinds of data sets really help people understand the whole environment and different layer of the 3D itself. It really helps the stakeholders to understand the importance from different perspectives. And I also got several questions for you. Here, this one. Let me find this one first. This one from Freya. Yeah, Freya. She is asking that the pros and cons of point cloud and 3D GS in BIM modeling or any of the projects you've already done, do they serve as efficient supplements to each other?
I think they're definitely complementary. Obviously, so we don't do BIM, but a lot of our clients do. What we notice is that a clear sight of the view of clear view of the site makes a huge difference in terms of the quality of the BIM model that comes out of it. So if you can't see clearly what's going on the site, obviously the modeling quality will suffer accordingly. And what 3D GS is bringing to the table is that photorealistic display, which for every operator is a blessing, because you don't have to try to decipher what the site is representing. Similarly, what we see on the point cloud side is the spatial accuracy. So I think the combination between the visual clarity that 3D GS provides and the spatial accuracy that the point cloud provides, the combination is actually a very magic solution, and I think it's going to elevate the BIM pipelines forward quite a bit.
Yeah, and I think their purposes are also quite different, and the targets for different groups of people. And we goes to another one. Is it possible to implement an initial model to correct errors to make the post-manual job easier? If yes, what is the most useful?
I'm not sure if I'm the best person to answer this question, but what we see from our clients is that there are a lot of different workflows, and it is a complicated sequence of applications that people use, going from the original scanner into the dedicated application, and then from there to recap, and then from there to Revit, and then ultimately from Revit they transition into a rendering application like Nubigon or Enscape and other platforms. It's really important to be aware of the issue, and if you plan accordingly, then you can actually avoid a lot of missteps that may arise.
Yeah. And I think with better visualization and the communication across different parts, and they may notice these different arrows at the same time. And I really like functions of Nubicons for making these contacts more clear.
Yeah, and what we notice is that if you have a clean setup in Revit, you can replicate that exact same setup in Nubigon, which we're quite happy to have solved Autodesk.
Yeah, exactly. And next one. Hello, guys. I think he is asking everyone what will be the next journey visualization in the 3D GS decade. So are we enter into a 3D GS decade?
I mean, it's definitely coming hard. That's for sure. I think I'm curious about the co-evolution of point clouds and 3GS, and I think that's why Xgrid is quite interesting and exciting for us and our clients. It's because it really establishes that bridge from the moment of the capture, and the clarity of the visuals and the spatial element. I think those are essential parts for any reality capture application, and the more they can align, the better. The more they can sync up, the better. And having that bundled in hardware or in a platform makes a lot of downstream efforts a lot easier. If you're trying to merge different sources of data, there's always some challenges that you may not be able to overcome.
Yeah, so even me coming from ASGRADE's team for 3DGS advocator, I still think it's not 3DGS decade, it's still a decade for combination of different technologies together. So that's why to combine different data sets together and you can transfer from one perspective to another clearly. And so that you get balance between the accuracy as well as visualization, even though 3DGS is a very good way for the representation of the reality capture. And we still need the context or different level of detail to illustrate the physics of the space itself. And I think the next generation visualization will be such combination as well. And we may have more powerful editing tools or maybe some AI powered functions for that next generation visualization. Maybe we will have better visual effects is one side, you have better visualization, and another one is that interactive visualization, which means that you can do some interaction or some immersive experience together within the only the visualization itself, but also to experience to or add any of the additional functions you need, or just to communicate your thoughts based on that 3DGS models, or not only the 3DGS or the combination of all of them. So that's my opinion as well. Yeah.
Sure. And I mean, it's interesting how anchors BIM also anchors downstream efforts. Talking about AI generated content, talking about different types of simulations. Reality capture is always bringing that that connection to the real world, and I think therefore it's interesting how it feeds not only these upcoming also provides an anchor point for all that. And the better you can represent reality, the greater the impact is going to be. And I always think the parallels between human five sensors absorb understand reality, and it's not only one sensor that does all the job. So similarly, for reality capture, I think it's going to be a multitude of sensors, a multitude of ways of understanding reality, and different visualization layers obviously will help achieve that.
Yes, totally agree. And I suppose this part is already finished, and then let's go to CRISPR of the last speaker for this webinar, and then later on we will have a longer discussion part. And let's invite CRISPR here.
So thank you, Mindy. So I think I can show the main video now. So let me share my screen. Okay. Can you see my screen? Mindy? Okay, yeah. Okay, that's the main video. So I will show my screen now with slides. Okay. Okay, so for those just joining, hi everyone, I'm Chris Aguilar from Reality Render Studio. I will walk you through the process behind this presentation. So, from technical data to visual clarity, that's the main focus of my work. Working with complex data, it's not a problem here. The main challenge is to making it readable. So everything starts with raw data. And we usually receive these formats like mesh model, point clouds, CAD drawings, BIM models, and in this particular case, 3D Gaussian splat. So this stage, what we are looking here is a typical final deliverable, and the data can be solid, but it's hard to read. You know, there is too much information, point clouds, CAD drawings, BIM models, a lot of lines, and everything is there, but it's not clearly structured. And even the Gaussian splat is clearly visual, but it's still not always easy to read when then combined with other data. And for clients and stakeholders, maybe this becomes difficult to understand. So this is where I come in with the visual direction. And most of the case, you don't need to show everything. That maybe can be confusion. And my role is to decide what to show, what to hide, and how to make it clear. So to let you know a little bit about my workflow, and to make this clear, I break it into 3 steps. The structure is where I organize the data and remove the noise or excess information. And then I compose, and this is where I define the main focus and how it's seen. And then finally, the refine is where I make it readable. So where we are looking here is the main part of the video that we just see. And make it clear. Yeah, at this point, everything is aligned, but alignment is not enough. The goal is to make it easy to understand and clear what are you looking at. So there is where the 3D Gaussian splat becomes really powerful because it adds a visual layer that helps people to understand the space much faster. And everything starts to make sense. So at the end, it's not just about looking cool or good, it's about to making it understandable. And finally, we have clarity make the right decisions. So when the data is clear, people understand it much faster. And when they understand it, they can make decisions with confidence. So that's where clarity makes the difference. And that's all. I don't want to make this presentation too technical, just a little bit about my workflow. And if you have any question or would you like to discuss how we apply this to your projects, I will be happy to connect and to answer any question that you will have. Thank you. Oh, you are muted.
Yes. Okay. How about now? Can you hear me?
Yeah, yeah.
Yeah, great. Thank you so much for this short presentation because we really have a long one and you really give it a very clear illustration of the whole things. And I would also like to invite all of the speaker come back to the stage and we have some open question here to discuss. And I would also try to select many of them from the comment area. And I think the first one that we should talk is that, yes, this one. From Willen, do you think that pure RGB based methods will soon achieve LiDAR scan accuracy with the help of AI? Have any of the speaker have relevant experience with all these tools?
I mean,
Yes, I have.
go ahead.
You can go ahead as well. But I think it will be 100% accurate then, because the point in itself has already RGB data, and that's why it's getting the accuracy from the point cloud directly. It's only limited to its physical conditions where light reflects and goes like this or this, but the pure improvement of accuracy from AI is 100% given.
I think the question is a little more about, visuals-based methods rather than, LiDAR-based methods.
Okay.
And obviously, there's incredibly advances in that space, but I think it's.
So you mean the smoothness from the picture it's getting, that you can read texts from it?
I think it's essentially saying, it's the Tesla versus Waymo type of debate. Tesla uses camera-based orientation, and Waymo uses LiDAR-based. And I think that debate is similar in this space as well. Obviously, photogrammetric or Gaussian splatting style reconstruction versus LiDAR-based reconstruction. Those are have been going on for a while. I think the way of thinking about it in exclusive is kind of the shortcoming. It's like, as I said earlier, we have 5 senses to perceive reality, and it's these hybrid data acquisition methods will, in my eyes, be the real solution. And one thing to also keep in mind that there's not one solution for every application. There's different accuracy requirements. You may not need the same LiDAR accuracy for a lot of applications. We in this context, we're talking about the AEC space, but even within the AEC space, there's a lot of variation on how much accuracy you need for various types of projects. So I think it's these are just different tools that hopefully will be combined in better ways in order to get yield the results that we need.
Oh, okay. Still mute the mic. And here, in my perspective, I suppose that RGB-based methods, also like photogrammetry methods, people have already adopted photogrammetry for the spatial capture for a long time. And photogrammetry can also get very high precision mesh models, and they can also to try to do some reversal for that point clouds. And when we goes to CDGS decade, and we have X-Grace has combined RGB photos together with LiDAR, just because that photos only have some RGB informations. But when it comes to the spatial capture, it always needs some information from depth, and the LiDAR is a very trustful or very stable or robust source of the geometry as well as the physical information. So that's why we try to combine the LiDAR together with RGB. And you also mentioned, William also mentioned that with the help of AI, at this moment, AI always use guessing or diffusion to do the reconstruction. So with this diffusion and guessing, something will be distorted. And so if you want to represent the reality in a very accurate way or correct way, so AI diffusing things will make you confused for some reasons or to some extent. So if your purpose is to do the reality capture, I think AI will do help with the visualization part, but not for the accurate or the representing the reality purposes.
Yeah, and I think that role is going to be different for based on the different applications. For in certain applications, you want a very clear view, you want a certain visual quality, but accuracy has a secondary role. So in those cases, the AI's role might be a greater role than in other scenarios where you really are dependent on that level of accuracy.
Yes, so that really depends on the cases. And when we're talking to scan to bin at this moment, I still think LiDAR will perform very important in the position, and those one are not be replaced in a very short time. And let's go to another question. I suppose this one is extra questions from Matthew today. So he said that, so am I correct that any deviation in accuracy ray-slam methods can be corrected using local control points in the field? I think this one is for Philip. I'm talking about relative accuracy and scale, etc.
I don't think control points do more accuracy in the 3D as well. I don't think so. I am not 100% the expert in 3D because most of the time I'm just using the point clouds and draw it. But just from my logic information, I don't think it's improving really that much. Maybe because the pictures have the same coordinates well, maybe it can, because the walking path is tracked with the time and the coordinates with the pictures and the heights, and that's where the picture knows where it is on the 3D. I haven't tried it so far, honestly, but I think it can, but I cannot really 100% answer it because I haven't tested it. The difference between when I used control points for just 3D and not for the same object. You needed to try the same object, same location, and then with control points and without control points to see the result of it. But I don't think it make a huge difference.
Yeah, so I think that for the scan to bin projects, the accuracy is really a good factor for the delivery. And for 3DGS, it's only a plus or a reference for those scan to bin projects. I think at this moment, it's not for all the projects. And maybe for the delivery, people have a better visualization things. People still need use that 3DGS for the display or the communication across different groups of people. And with the control point, from my experience, I really do different kinds of scans and try to compare them with or without the control points. And the fact is that it really differs from the environment and the scale. For example, if you only scan house, a single building, that one will be very simple with SLAM. And if you want to do a multi-story building or multi-room buildings, sometimes SLAM may have some like deviation of the accuracy, and point clouds always be helped with the control points. And just because the X solution rely heavily on the LiDAR and the SLAM system, so that 3GS output really rely on the point clouds result. So if you make a control point and get a better point cloud, then you really get a better result for 3DGS as well. Yeah, so that's my answer. And another one is for CRISPR from Freya, our friend. To CRISPR as a technical expert, how do you see these visualization platforms benefit in technicians' workflow or a general business scenario? I think this one also goes to Bert as well.
Yeah. Thank you, Freya. So yeah, I come from the scan to bin industry before I focus entirely on the visuals. And when you are doing modeling work, you need to double check the data that you are representing. So you have to go to 360 photos or that we capture with the LiDAR scanning, which are usually in low quality with colors that don't match with the reality. So you having a Gaussian splat model that replaces a virtual tour and also has a structural geometry now that can be overlaid to the Revit model or LiDAR model is a game changer for me. In the visualization part, I think it adds a strong visual layer that makes the space easier to understand, and especially in areas with reflections or surroundings, and if it has been captured correctly, you will have your surroundings for your project. And it will help to understand quickly without any explanation. That's it.
Yeah. Bert, have you got any additional points for this question?
I mean, technicians are humans too, so if they can see better, if they can get a better understanding of the space, if they can get better understanding of the site, then their work will be higher quality. And quality assurance and quality management is a huge issue in the scan to BIM industry. There's a lot of effort that goes into ensuring that what has been scanned is modeled accurately and reliably. And anything that helps the site to be displayed in a better way, in a more understandable way, that enhances the internal workflows, the work of the technician, and ultimately the final product. And I think that's something that is probably without question. And so you have benefits for companies internally, but also in the way they can present the data to the outside world. The AC market is huge. Scan to BIM is still relatively small compared to it, and there's a lot of people that haven't heard of these technologies, are not really familiar with it, and it's if you can show them visuals that are more appealing, visuals that are more insightful, then it's easier to communicate that and get them on board. So I think it's also a great technology for technology adoption. And it reinforces itself.
Yeah. And also for Philip, I think in the previous projects, you always deliver the CAD, the BIM files, or some videos for the showcasing and delivery. And maybe, do you see any potential for the future, maybe the visualization platform delivery so that people can collaborate within a platform and add any of the annotation for their insights and requirements? Is that possible for the business scenario?
Also, I use these visualizations most of the time because it's as he said, it's still a little bit a niche, and you need to. Most of the people who say we do this, we do that, they have the budget. Most of the time they're still they're very old and they don't are that technically aware of this thing, and that this can already is a thing, and this is faster and this is cheaper. And that's why I think it's a good thing to visualize it and to use it for marketing purposes and for explaining purposes, that everybody can see it, that you don't need any kind of super fancy device or software, that everybody can see it on a video. Hey, this is scannable, this is how it looks before, and this is how it looks afterwards. And then this is the result, and that is what we're getting.
Yeah, exactly. And after all these questions be answered, I also have several ones to talk about. And the first would be, let me see, where do current, as we already go through the scan to BIM workflows from the capture to delivery to show visualization and communication, and what do current scan to BIM workflows still break down today, even with better capture and visualization tool? What kind of breakdown you see? Any of you can answer the question.
So we talk to scan to BIM. We have obviously a lot of users who are doing scan to BIM, and in a lot of cases, in my eyes, the
the projects break down when communicating the value of it. And I think that's not necessarily a technical issue. It's more of a business issue, like a communication issue. Like there are obviously scan to BIM is very complicated. The workflows are probably more complicated than they should be. They have a lot of pitfalls. If you don't have your system and your pipelines lined up correctly, then there's a lot of issues that may arise down the road. There's a lot of QA/QC issues. But I think what a lot of people struggle is really to communicate the benefit, because having the reality as an anchor is so intuitive. If you think about AC is all about the physical reality, right? If you don't have a good understanding of the physical reality, then your work won't be as good. So if you're doing any type of construction, any new project, any new civil engineering project, any urban project, it will be better if you deploy reality capture, if you deploy scan to BIM, if you're working towards a digital twin era, then it needs to be grounded in reality. So and to communicate that value, I feel like is a shortcoming of a lot of companies that maybe are too caught up in their internal workflows and the operations, and maybe don't have enough time or the resources or the awareness of communicating that to the outside world. And I think that's and the more we can help people do that, the better, because it's obviously going to elevate the entire industry. There's all these discussions about why construction isn't getting more productive. It's the only industry in the world that
Yes, and when I can link on that, and I think it's still a big budget problem, because most of the project managers, they don't even recognize that they say we scan this and we draw this, and everybody now has the same basement file and everybody can work on this, and they don't need to get with every different, with the electrician, with the MEP guys, or with several professionals to go there. And at the end, even with the costs, some will say, here we haven't seen that, we haven't calculated this, and this sort this is kind of an, I don't know the English word.
You can say it in German. I can translate it if you
Beweis.
Proof.
Yeah, the proof. Yeah, exactly. The proof. It is a proof for everybody that this is how it was, and everybody can make based calculations on this. And afterwards, you basically, I am a 2-in-1, for example, as my part, a survey and an architect. So in my reality so far, I think most of the project managers haven't recognized that you are faster, cheaper, better, more accurate.
Yeah.
And this is what Bert told. I think this is a communication problem. So you need to be, as a CEO, a good salesman to give the values and the benefits of your service to the client.
Yeah. So how about CRISPR? Do you have any other information or insights you want to add?
Oh, that's not my specialty, so I let this question for now. It's not, yeah.
Yeah. And I think I got the last questions. So it's about looking ahead. So where do you see the biggest opportunities for extending this workflow beyond the factory or construction into other industry, infrastructure, or building scenarios, maybe urban planning, or any of the things that you want to foresee for in the future?
So obviously, the more we capture the physical world, the more we can build on it. So if you're scanning individual construction sites, individual localities, then that's great on a very small micro level. The more you can scan, the more you can scale. So smart cities is obviously a culmination of all those efforts. If you have a thoroughly scanned city, then you can work quite effectively and deploy urban planning and city management decisions on these applications as well. I think there is an infinite amount of growth potential with regards to what you can do in terms of capturing and then extracting information from it. So, one area, the one question that I've personally been quite invested in, that a lot of property owners don't really know the exact square footage of their properties, because it's hard to get to. Like those phone-based applications do a great job, but if you're a big property owner, so to know the square footage of your facility is probably the most important thing you have to know about your property. But a lot of property owners don't. So facility management and property management is another area where I feel like reality capture and scan to BIM is going to come in handy. And scanning once isn't a one and done type of thing. So you have the 4D element. You scan, and then the world changes, the building changes. So scanning it over time, I think, is another area where we're going to see a lot of progress, especially as scanners become more affordable, they become easier to use, they become lighter, they become smaller. So it's going to become more of a day-to-day operation that pretty much any site manager or any superintendent of a building will be able to deploy at some point. And obviously,
exactly, as you mentioned before, Tesla is that already doing on the streets. They're basically a big data acquiring company, which are capturing a lot of 3D data. They are using this as well for mobile mapping and such things. And I think, for example, I don't know, Bert, where are you from?
I'm half Austrian, half Turkish.
Half Austrian, okay. We Austrians, we are the historic pro measurements and surveys from history. And we have in Austria called the GIS, and every square meter is measured. But this is just 2D, and maybe it could be a big dream that every part would have a digital twin scanned on it, that you can see the 3D world of it. So like 30 years ago, everything was measured, and now is it in 2D plans and online visible, and maybe in 20 years, everything is captured with a LiDAR scanner, and then everything is online, everything watchable in 3D with a digital twin.
Yes, and from my side, and I also think that I totally agree with Bert's and Philip's points. And I suppose that those visualization nowadays is for decision making or the communication across different groups. Maybe in the future, we will also make this communication together with robots and more computers. And but robots at this moment is not think like people. They have sensors like cameras, and they have LiDAR as well, but they don't really understand the space or the construction itself or the factory, for example, the factory case that we mentioned today. And if we want the robots can carry a mission correctly in a space, in a 3D space, not only a 2D floor plan, because the robots are facing more complex environments in the future, and they are going to carry more complicated missions, so that the basic for their spatial recognition is the capture of the reality. So those visualization is not only for decision making, and maybe in the future the efficiency of decision making, or the efficiency or the accuracy of the mission carrying. So that's the basic of spatial intelligence. And and we know that LLM, or large language model, these days, they have really large scale data sets, text, videos for the data training, the AI model training. But for the robots, they have very few data sets for those 3D understanding and the spatial understanding. So that's why I think that will be the future direction for the spatial capture, reality capture, as well as the spatial data sets.
Yeah, and I think that's an important point for a lot of scanning companies, because a lot of times you get paid once for one data set, but all those data sets are actually assets. They're digital assets that they may not be valuable at the level yet, but they will become over time. The more because there's that 3D data is a very valuable training resource for a lot of these physical AI applications, and it's going to be incredibly valuable to a lot of people. So it's
yeah, maybe I can provide someday all my data sets, 50 terabytes of point clouds to NVIDIA to train their AI, for example.
Yeah, exactly.
mean,
Those data sets are very valuable.
Yes.
And and I've already got my question answered today. And still, I got one, the final one, the last one from the audience. And when we finish this, and we will go to an end. So this one comes from Daniel from LinkedIn. How do you educate and convince the market and clients that they need this? And how is the post-sale and delivery process? It's a really good question.
Yeah.
From Beat or from me?
So
We can go both.
I think any of you can answer the
Yeah.
question.
Okay, I can start. How do I convince the people? I tell them they have a problem, and I make the problem that big that I am the only solution, and they now recognize they have a problem, and then and then they're gonna say, "Oh shit, we need to capture this because we need clean measurements because we want to build in 2 years something, and now we need to scan this because now it's empty, and then it will be full, and then it's not doable." And we need accurate plans for this to make some construction changings. And that's most of the time my convincing. It doesn't is a convincing strategy. Most of the time, people who need it come to me, and because not that many companies in Austria currently can do both modeling, MEP, and do the scanning part. And the post-delivery sale process is, I think in Austria, it's very uncomplicated. Everybody, I think, is fair. And when you deliver what you promised and what you offered, everybody will pay you. So I haven't any troubles so far.
Yeah.
Yeah, I think.
How about Bert?
Yeah. So convincing is an interesting.
It's the wrong term, yeah.
Yeah, it's an interesting term because at the end of the day, all of us are selling some sort of a technology, but sales is always emotional. So even though if you're selling something technological, the sales process is emotional. So you need to be able to understand people and communicate with them, and see where their needs are, where it hurts, where their pain points are, and and the way and a convenient way to reach them in helping them out. I think that's something that is slowly progressing with our industry, to understand that you can't just send someone a data set and be like, okay, here's your model, ciao. That's not enough. That's not really the point. They want to have the confirmation. They're buying the trust in what that
Exactly. I always like to share screenshots. Here you see the difference, point cloud to model. You see how accurate it is, and here it looks before and after, that they can share, because they don't work with it. They can just see the images, as Bernd said, and they say, okay, that looks great. So let's go on.
Yeah. I think
yes, don't convince them, just show them.
yeah.
Now
So,
let your work say everything.
Yeah.
That this is the proof of your quality.
And these
Yeah,
are great ways to communicate trust, and I think that's a rare property these days, to be able to communicate trust. And if people have an easier time believing it and trusting it if they can see it.
And the easier, for example, with Bird, they have a product, a digital project, and the better the product is, the less you need to be a good salesman, because the project speaks for itself. Then it's easier to bring it to the man.
Yeah.
Yeah.
Maybe
And
before we wrap up, maybe we'll let CRISPR play the video again, so we can.
Yeah. Okay. Let me show.
CRISPR. Yeah, we've already finished the question part. So then let's go to the video part. And this webinar will go to an end.
Yeah, okay. So can you see?
Not yet.
Oh.
There we go.
Okay, let's go. Yeah.
Yeah,
So that's
I
it.
suppose that all the most of the questions has been answered today, but still some of them are left in the comment area. And any of you can go back to that questions and have a further communication. And we have a really good night here in China and the different parts of the different time of the world. And in the future, we will also have more webinars talking about real use cases as well as the new technology being applied into the scenarios. And thank you, many of you coming from all different parts of the world. And thank you for every speakers for today's. And then we will say bye for today.
Okay. Thank you.
Okay, bye bye. Thank you very much. Bye bye.
Bye bye.